Hello everyone. Today we are going to know about left factoring. So, left factoring, it is a technique used in formal language theory and compiler design to eliminate common prefixes in the production of the grammar. So, this technique left factoring is used in compile, compiler design, uh, which is helpful to eliminate the common prefixes in the grammar. In a grammar, when multiple productions share a common prefix, it can lead to parsing conflicts and inefficiencies. Like if more than one common prefix have been present in a grammar, there will be a conflict or a confusion to that which prefix or which state we have to move. So to avoid this confusion and to avoid this conflict, left factoring is used. Left factoring aims to resolve this issue by transforming the grammar into an equivalent form that removes the common prefix. So in this left factoring, it resolves the issue by transforming the grammar. So usually the grammar it will be in a non-deterministic state. Then after the left factoring, the grammar will be converted to deterministic grammar. So which is useful and which helps us to avoid the conflict. Non-deterministic grammar is nothing but the grammar which has to more than one state. Like here in the example, A has A alpha 1, A alpha 2 and A alpha 3. Here there is a conflict arising that where A should go. Like after A, it should be going to alpha 1, alpha 2 or alpha 3. So these are the three states which this capital A has. So here it is a non-deterministic grammar. After left factoring, we can convert this by giving a prefix or any other extra non-terminal prefix so that which avoids the conflict. Here A goes to A dash. A dash is nothing but alpha 1, alpha 2 and alpha 3. So if you want to find A alpha 3, then we can only take this value. We can neglect these two values. So in a pass tree, we can go on A and A. In A dash, we can give directly alpha 3 if we want A alpha 3. So it depends on the prefix, giving a common prefix to the strings which are more. So left factoring algorithm. Here are some of the steps which has to be followed during left factoring algorithm. Step 1, identify common prefix. We have to firstly identify the common prefix from the given grammar. Here, common prefix for this a capital AR, A is small a. In these three, we have a small a as the common prefix. So firstly, we have to identify the common prefix. Then we have to create a new non-terminal. New non-terminal is the prefix which identifies all the different prefixes or the strings which are being used. So here a non-terminal is capital A dash. So it represents, it can be either alpha 1, alpha 2 or alpha 3. Any of the three can be represented by this A dash, capital A dash. Then split production. After creating a non-terminal, we have to split the production. Like for splitting the production, this will be getting to know in our examples. Given prefix will be splitted to the given grammar. Then update production. Then we have to update the particular production which is being given. Resolve recursion. This recursion, uh, resolving recursion can be used if there is a recursive grammar or recursive strings or prefix which are being used. If there are no recursion, then no need to use this step or resolving the recursion. Then repeat the process. The same process has to be repeated till all the repeated prefixes are repeated prefixes have been solved, and the grammar is converted from non-deterministic grammar to the deterministic grammar. Our first example here, A to AD, this pipe represents or. This is the production given in our question. AD, A or AB or ABC or B. So this, firstly we have to identify the common prefixes here in the first step. So here common prefix is A in small a in all the four strings given. A and A. So this can be represented as A to A, and these D here nothing is there means it is considered as epsilon. A, D, B and BC are being represented as A dash, and B it is written as it is. So our A dash is nothing but the remaining of the common prefix D or epsilon. Here nothing is there, so nothing is there means it is considered as epsilon, then B and then BC. So here in A dash we'll be having a common B and BC. B is a common prefix in B and BC. So in our next step we are going to solve this. Split the production. Here we are splitting this production and we are going to update now. Here is the updated one. We have to solve the recursion. So here B here are repeated. So A is A dash or B. This is the first step. Then A dash it consists of B and BC, which has B as common prefix. So B is taken as common, and here epsilon and C are been represented as A double dash. So here A double dash is nothing but epsilon or C. So here one more example. Here A to AB capital B or A capital B, CDG or CDEB or CDFB. Here is a given grammar. So we have to convert it to a deterministic grammar by left factoring method or using left factoring algorithm. So firstly, in first and second strings, we have A as common prefix. So here A to A, then A dash. B, capital B and B are represented in the form of A dash. Then remaining strings are being written as it is in our production. So next here we have written A dash. A dash is B and capital B or B. The left out of this first two strings like B and capital B are being left. So in this production, CD means remaining three production here, CDG, CDEB, CDFB. In these three, CD is a common prefix. So now we write as it is A dash, or in these we have CD as common, so we have written CD as it is, and then G, B, EB, and FB. In these three, to represent these three, we have taken a terminal A dash, a non-terminal, new non-terminal A dash. So here A represents B, capital B or B. A dash represents G or EB or FB. So this was a non-deterministic grammar which was given in our question. This is a deterministic grammar which do not have any repeated or common prefixes. So we have removed all other repeated prefixes. So our algorithm is been satisfied. We have resolved your recursion. Then finally we have again repeated this the same process, then here after everything, so there are no recursion or we do not have any repeated comments, so we'll stop this process here. Thank you.